Welcome to another tutorial. Today we'll discuss autofocus. Autofocus is the fact of letting the software focus your equipment using predefined information. Two pieces that are critical is knowing the step size of your focuser and knowing the critical focus zone of your system. I have an Optec TCFS2 which has 2 microns per step, per encoder step that is, and my critical focus zone is 100 microns wide. This information is critical to know. Doing some cursory searches on Google, you'll find the right information. That again is critical focus zone and your autofocuser's step size in microns. Let's take a picture and see what we have. I'm taking a 5-second exposure, binned 2x2 to speed up the download. Let's start our autofocus. We go click on Observatory, Focusing Actions, Automatic Focusing. Again, Prism asks us to pick a target. Let's pick this star down here at the bottom. Prism asks us to confirm, do we want to use 5-second exposure, the SX814 main camera, and Optec TCFS. Prism asks you this just in case you have two separate setups for imaging. You could have one setup that has the 814 and Optec, and you could have, for example, an 80mm apochromat with another Optec per se. So it is important to define which one it is. We'll press yes to continue. We are presented with this window. Let's go through it piece by piece. The top left side is the subframe where the star will be displayed and calculated. The top right side will be all the information that's going to be displayed, like the loss for width half maximum, HDF in pixels. The bottom is the information that is required to be entered. For my focus, I use 13 iterations, which means that Prism will move the focuser 50 steps. Remember that my critical focus zone is 100 and my step size in microns are 2 microns. So I'll use 50 steps for each iteration. We need to define a starting point in steps and an end point in steps. Prism will automatically find the center point, and it will do these increments 13 times. Some important information here: the system focal length in millimeters minus 1380, the diameter of the scope in millimeters minus 250 or 10 inches, and pixel size binned 1 by 1, which is 3.688. It is important to go back to the video of equipment selection and connection and set up your information in the hardware tab. Settings, hardware settings, cameras, camera number 1. It's important to establish what these numbers are and put them in the right place. Press OK, OK. Let's go to the next tab, image grab. Here we can tell Prism we want a nominal exposure of 5 seconds, maximum exposure of 10 seconds, and a minimum exposure of, let's say, 1 second. Half window in pixels, mine is 35 per side, so it's 35 pixels per side. HDF analysis radius in pixels. Prism is going to search for the centroid for a 10 pixel radius. There are two methods to calculate focus. One of them is HDF or for width half maximum. Automatic star shift So this will move the telescope to keep the star centered in the subframe. We can also wait for a stabilization time after focus motion and just before doing an exposure, which means Prism will wait a number of X seconds that you specify before each move of the focuser. This just in case you have vibration in your system. The next tab, Outputs. You can tell Prism where to put the log file that's created out of the focusing that you do here in automatic focusing. You can save small focusing images and you can indicate where, and you can graph the focus front at the end. I don't want to save any small focusing images, and I'm ready to press execute. Let's do that. I will open the focuser control panel just so that you can see the focuser moving. As you can see, it's at 1400. We specified that this is our starting position. Then Prism will move it and it'll calculate the HDF. Right now it's 8.8 pixels. The encoder steps are displayed right here. Now we moved it to 1500, and as you can see, the HDF is getting smaller. Bear in mind that the star should be large, like a donut, and starts getting smaller and smaller and smaller as we move towards the best focusing position, and then we go past it, and the star keeps getting bigger and bigger and bigger. This is what we refer to as a V-curve. You will see this displayed at the end. Here we are. Let's examine the curve. This is what happened. So we were outward, all the way out, almost 9 HDF, and then it got sharper and sharper and sharper until we reach about 5. So as you can see here, the optimum is at 1622 encoder steps. The HDF was 5.1 in pixels, which is here. And then it kept getting larger and larger and larger until we almost reached 14 pixels HDF, as is displayed here in the last step, which is 13.4. This was automatic focus. This is very useful to quantify your system, or for example, to figure out where your filter offsets are. You can run this for every filter 3 times, average out the runs, and you can establish your filter offsets. This is also good to just focus manually to double check your optimum focus position. Next, we'll discuss direct focus. And again, thank you very much for watching, and stay tuned for the next video. Thank you.